Morning all. My name is Ramesh Bhaskaran. My co-authors are Badrinath Sankaranarayanan and Kopayaraj Karupaya. Paper ID 253. Before proceeding to the topic, I would like to thank the team who has organized this event and who has supportive and has given cooperation. I would like to thank. Today we will discuss about identification and analysis of barriers for in-service inspection of pressure vessel and piping using DEMATEL approach. During the breakdown or in operation or due to any planned maintenance, the in-service inspection will be performed. Uh, this will uh, this will be used to analyze the condition of the equipment. Uh, this will reduce by implementing this in-service inspection will reduce the downtime and it will be cost effective. So in this research, we have identified the barriers for the in-service inspection, and we have analyzed those barriers. Uh, we have chosen 20 essential barriers uh, based on the literature review and opinion of experts. In this research, we have used DEMATEL tool as a multi-criteria decision making. Uh, Based on the analysis, we have identified that some of the barriers which will be most influential, and this will be helpful for the owner or user of the equipment uh, to take as a proactive measures. So most influential factors are a lack of manufacturer design parameters, material specification of the equipment, and unavailability of the nameplate are the most important variables. So let's discuss in detail about this topic. Inspection is an examination uh, which will be used to determine its conformity based on the requirement or a professional judgment or client requirements. Pressure vessel is a container which is designed to withstand internal or external pressures. Based on the application, the design will vary. And materials also, carbon steel, uh, stainless steel, and FRP can be mostly used. Um, and design temperature will vary based on the requirement of the user, and it can be a horizontal or vertical type of pressure vessel. This study, we can improve the quality of inspection, and it will be easy to identify what are the important barriers which affect the quality of inspection, and we can analyze the effect of individual barriers over the other barriers. So the main scope of this research, which is focusing in service inspection. The inspection will for the pressure vessel. The inspection will be performed during construction activities, during installation, and while the equipment is in operation, and the equipment during repair or alteration. So our focus is to do the analysis uh, during in-service inspection. In this research, we have used DEMATEL method. It has some of the features. It is a compensatory method, no need for the independence of attributes, and the quality of attributes are converted into quantity of attributes. Literature review, we have uh, focused the DEMATEL methods in what are the inspections, especially in-service inspection related to the um, pressure vessel and piping, and some other process industries. What are the barriers that we have reviewed? Will be the research methodology. First, we have identified the panel of experts who has the experience related to pressure vessel and piping. They should have a APA 510, 570, and welding and corrosion inspection related certification. So, based on the input from the experts and the literature review, we have to get we have to define the inspection barriers, and after that we have to construct initial relationship matrix and average relationship matrix, normalized direct relationship matrix, and total relationship matrix. Based on this, we can get cause and effect values for each barriers, and we can analyze the interrelationship between the barriers and ranking of barriers. These are all the barriers that we have defined based on the literature review and expert opinion. So we have given for an notation for each barriers B1 to 20. So initially we can make initial direct relationship matrix. This will be given by the expert opinion uh, based on the interrelationship between the two barriers. If it's no influence, then it will be count as 0, and if it's very high, then it will be written as 4. After the formulation of direct relationship matrix, then all the direct relationship matrix will be averaged. So average relationship matrix will be constructed, and normalized direct relationship matrix also will was calculated. Total relationship matrix also calculated. Uh, cause and effect values was developed. After that, interrelationship map also developed. In this DEMATEL approach, we have obtained the ranking of barriers, and finally, based on this analysis, we have identified the most important barriers which is to be focused to improve the quality of the inspection. um, and we have identified some of the interrelationship between what are the between the barriers was identified. So this is the most influential B3 we have to focus, um, because if there is no manufacturer design parameters, uh, lack of design parameters, lack of metal specification, and if there is no nameplate, then it will be difficult for the organization to uh, do the inspection. So further, it has to spend more time to develop the inspection process scopes, and it will take more time-consuming process. As a user, they has to focus uh, the manufacturer design parameters and material specifications. These data should be available and it will be provided during the inspection. And based on the interrelationship, the most influential barriers B3 and B4, which has more effect, and some of the barriers uh, B15 pressure hold PRV testing, and foundation. These are all. This will not have an effect with other barriers. So, as a conclusion, this will be useful for the organization. By focusing on this important parameter, we can improve the quality of the inspection process. Um, this research provide some management implications for pressure vessel and piping in service inspection. This will be helpful for the owners or users, asset integrity managers, teams, the personnel who is involved in the activity. One of the forms that we have used during this analysis. Thank you.